Now on the inverse of the parabola. Okay, let's start off by doing this and saying, remember yesterday when we found the inverse, what did you do? We interchanged the x and the y and then solved, right? We're just gonna do the same thing here, okay? So f of x equal to x squared, then swap x and y just as we did yesterday. Okay, so that means where there is y, I now put x, and where there is x, I now put y. That's what you do. Okay, so now if I want to solve for y, what happens? I'm going to take square root, right? Okay, so I'll take the square root here and take the square root there because I want to solve for y. So to remove the square line, take the square root. So what that means is that y becomes plus or minus the square root of, remember when you take a square root, the answer is always a plus or minus.
Yes.
So what that means is that our inverse is plus or minus the square root of x. Right. Obviously, when you find an inverse, what you have to do? Draw the graph of the inverse. Okay? Remember what I said yesterday. For you to be able to draw the graph of the inverse, you need the original function.
Yes.
Okay. So, let's do the graph of the inverse. Okay. Right. Okay, so that's the y-axis, that's the x-axis, okay. Right, well, what is the graph of x squared? Wow, we know this one, right? It's this parabola here, which is a turning point at 0, 0. That's the graph of x squared, isn't it? Okay, now, remember when we draw the inverse, we need the points on the original graph that you're going to swap around to get the points for the inverse, isn't it? Okay, let's try to find some points. So obviously, if this point is 1 on the x-axis, it also becomes y on the y-axis. Why? Because 1 squared gives us 1 anyway. So if we sub 1 into f of x, we're going to get 1 for y anyway. And even if we sub negative 1 for x, we're still going to get y. So that means we have this coordinate 1 and 1, and we have that coordinate x negative 1 and y 1. Okay, what other coordinates can we find? Well, what if x is equal to 2? Okay, so if x is equal to 2, you square 2, what you get for the y, you get 4, isn't it? And same thing, you square negative 2 on the x, you still get 4 on the y. So we've got another coordinate there, where x is equal to 2, y is equal to 4. And another coordinate there, where x is equal to negative 2, okay, don't mind about the accuracy, y is positive 4. Okay, now I want to draw the inverse. So obviously the inverse is going to meet here because that's a line y equal to x, isn't it? Okay, so this one, yeah, unless they ask you to draw the y equal to x, you don't really need to draw it. Unless if they ask for it, then you do it. Okay? But what you're going to need to know is that, remember for the inverse, this swaps the other way around, right? So we're going to need a point where y is equal to 4 and x, sorry, this goes around. So x now 4, y now 2. So which means the point is here, right? So we write this the other way around. What other point? Okay, this one was already there. Right, we need another point to reflect this one. So a point where x is positive 1 and y is negative 1. So we now need that point, right? Where x is positive 1 and y is negative 1. And then we need another point where we're going to swap this around. Okay, so we need a point where x is positive 4 and y is negative 2. Remember, for you to find the inverse, you swap the points of the original graph. Okay, now let's draw this graph now. We obviously going to join these points, join that point. That's now a turning point because the graph is going to come back there, and come back there. Right. So this is the graph of f. That is the graph of f inverse. Now, here's the big question. This f inverse that we just found, is it a function, yes or no? Is this a function?
Yes.
Are you sure? Remember, when you want to know whether it's a function or not, we draw the vertical line.
And see, yes,
it's not a function. Yes, because if I draw my vertical line, it's going to cut 2 times.
2 points.
So this is not a function. Yeah, they say, why do you say so? Well, because of the vertical line test. So remember, when we find the inverse of a function, we expect it to be a function. Now, this inverse is not a function. So what are we going to do about it? That's the question, right? Okay, this is what we do when we're dealing with inverses of parabolas which end up not being functions. To make f inverse a function, we will have to restrict the domain of f of x, right? So we will have to make f to have a certain domain that we want, right? Because we understand that if we take the whole f of x, it's not going to... So you have the first situation where you're going to restrict the domain of f of x as follows. Remember, the domain of f of x is any real number. Now this one, we're going to say, well, this is any real number, but we're only going to take values that are greater than or equal to x. Okay? So let's see really how this is going to work out for us. Okay, so y-axis, x-axis, okay, let me see. Alright, so this is our original graph, right? The f of x is equal to x squared, this one that I'm going to draw with a pencil here. Okay, that's our original graph, right? But now, we are using a new domain for this graph, okay? So we are only going to take values where x is greater than or equal to 0. So that means we're only going to take this to be our graph. We're only going to take that because the domain is restricted. Okay? So when we only take that, we're only going to find the inverse of that. Okay? So let's remember we need coordinates. That's what we're going to swap around. Okay? So we have the first one here, x positive 1 and y positive 1. We have another one here, x positive 2 and y positive 4. Okay, so we have this coordinate 1 and 1. We have that coordinate 2 and 4. Now, remember this side doesn't count anymore because I have cut out the domain. So if I now want to draw the inverse, okay, obviously it's going to go through here, right? And now I need another point where x is 4 and y is 2. Let's have it somewhere here. Okay, x is 4, y is 2. So that means my graph is only going to look like that. And it's only going to start here because remember there's nothing to reflect from that side. So my graph is only going to look like this. My graph of the inverse. Oh, that's a function. Because if I draw my vertical line, it's going to cut once. Now that's a function. Okay? So that is one way in which you can restrict the domain of x squared to end up with an inverse that's a function. Okay, so this one is a function because this is the original. Okay, so that's situation number 1. That's what we can do.